Hi, my name is Sam Schur, and on behalf of Corescan, I'd like to welcome you to our talk entitled Detailed Mineralogy and Texture Using Hyperspectral Pore Imaging. So spectroscopy, hyperspectral, has been around for a long time, spectroscopy now, over 40 years. Satellite data, airborne data, many of you are probably familiar with the ASTER system, Worldview 3, more recent. This to the right is a picture of an airborne system, HIMAP. This is a picture, or map rather, of Afghanistan with the hyperspectral imagery draped on top of it. Some of you might also be familiar with handheld systems. This here is a Terraspec Halo, but the PIMAs came out in the early 90s. What many miners, many explorationists do is they take a single point, and usually every meter, every other meter, one core box. And that's what that's giving you is giving you information potentially on the mineralogy that you have in that single point. Minerals, it's called a spectra, and minerals, especially alteration minerals, tend to have basically a fingerprint, and that's what we call spectra. And so you take that, and then the next scale up that you can get, or down, depending on which way you look at it, would be looking at hyperspectral core imaging. This is a more recent innovation. The Corescan system itself images at 500 micron pixels and delivers then approximately 200,000 pixels in a meter. So what you're left with, instead of just getting a single point that could give you maybe 1 to 2 minerals, what then you start to see is a whole slew of minerals. And you get to see a map of these minerals distribution, their spatial relationship to each other. So here, on the left, you have a picture of a Corescan lab going on site. This one in particular is going to a project in Alaska in the US. And then over here is a picture of our actual system scanning some core. Fundamentally, what are we doing here? What are spectroscopists doing, and how's our technology working? We're using a portion of the electromagnetic spectrum. We're using the visible near-infrared through the shortwave infrared when we're talking about Corescan. And what we're essentially looking at are these regions over here. And this will be able to identify mineral groups such as clays, sulfates, carbonates, micas, amphiboles, iron oxides, and a whole slew of others. Essentially, when you're looking at when you're particularly looking in the VNIR, you're looking at electronic absorption features, and that kind of leads you to just about 1400 nanometers. And then it turns over more to the vibrational absorption features. And all this is to say is that minerals have bonds in them, and these chemical bonds interact in different ways. And for example, if you have taken a point where there is some carbonate, those carbonates, we're able to identify them because there's specific features. Here, for example, here, the more famous one at 2340 nanometers, where these different absorption features are saying diagnostically that you have a carbonate here. And that's what's happening for many, many minerals. So when you talk about, well, what can Corescan do for my project? Can you look at chips? Can you look at whole core? Does it have to be split? Does it have to be cut? We can look at all of them for many reasons that we can talk about later at the booth. But we image tons of different materials. We image soils. We work on blast holes. If you're in the oil industry, we do a lot of cuttings. All these can be imaged and analyzed without issue. In terms of where we're located, currently we have operations spanning the globe. We have bureaus set up right now where you can ship your core to so that we could have a quick look, do a trial. We have them set up in Santiago de Chile. We're in Hermosillo, Mexico, as well as in Perth, Australia. And otherwise, where you're looking at these other little Corescan points are just different areas where we have on-site laboratories working with specific companies, and where you can see the 24-hour signal. That indicates that that lab is operating 24 hours a day. When we come to site, the lab is fully self-contained. You're looking at a project that we had going on in Chile. It comes in a 20-foot sea container. This way everything's protected, everything's ready to go, especially when you're scanning. You don't want any particulate matter, any dust coming in. You don't want anything to affect the way the spectrometers are working, all air conditioned, heated, etc. It's turnkey operation, real-time data processing if that is what you're interested in having for your particular project. And we can support 24/7 operations. Our services, when you talk about our spectrometer in general, or more specifically rather, our spectrometer, we're looking at, we're giving you high resolution core photography, 50 micron pixels. So you're looking basically, you're at the drill hole scale, you're looking at it at close to a hand lens resolution. We have 3 completely co-registered infrared spectrometers in the VNIR and 2 in the SWIR. Those are at 500 micron spatial resolution and about 4 nanometers spectral resolution. And then we also have a laser profiler that's mapping core morphology. And this we use for geotechnical applications, and that's at 500 micron spatial resolution and 20 micron height resolution. And all of these are completely spatially co-registered. Corescan outputs, so we have images. That is probably our most infamous thing that we have, most famous rather. So we're capturing high quality data and we're capturing mineralogical complexity, the variability. These are some examples of some chips from a project, and in each chip tray, which can be variable, but we're collecting, in this case, about 1,500 spectra, or pixels rather, over these trays. And also, not only are we collecting all this data, so here, for example, you have the map of saponite. Here you have a map of quartz occurrences, chlorites, iron oxides, kaolinites, white micas. Not only that, but all of our data as well comes in CSV format. And that CSV data can be integrated with a whole, with anything that accepts CSV. So whether it's one of our partners, or it's a database that you have, a statistical program that you're using, a different 3D modeling program, this can be incorporated into all of them. So an example workflow, how would I go about using this? You could, you would first collect, say, your data. You could do a quick log. Then you would scan the core. There would be a spectral data interpretation of it. Then you can use the images in a specific way, whether you're going to use them to help you core log, you're going to use them to maybe do some textual analysis for geomet. You can also use that semi-quantitative mineralogy to help with and integrate with complementary data sets, even whether it's chemistry, geophysics, use that for some machine learning, use it to help improve your existing 3D models. This is just an example. There's tons of different ways that you can use this data. Also, just taking note that images themselves are data. So I think for a lot of us, it's much easier to take that point data and to use that because it's numbers. But on the other hand, images are data as well. So you can use this, for example, for textual machine learning analysis very readily. This is an example, another example of some of our spectacular imagery. This is looking at a porphyry deposit in South America. And the final thing that I really wanted to touch on was just that in addition to having all this incredible mineralogy, we also have geotechnical capabilities. So, and not only do we just have this, we have the laser profiler for core morphology, but we also have, because we have a co-register with the photography, using that in conjunction with this RGB imagery, it provides advantages over other systems because you can tell whether something is, for example, is it a fracture or is it actually a vein? So, and in addition to that as well, because we have the co-registered mineralogy, you can also say, well, what actually is in that fracture? So it's all very interesting. And again, come see us at the booth. We would love to talk to you more about this. So what is the role of hyperspectral core imaging in the mine cycle? It's honestly everywhere that we've been operating. It's changing the way that geoscientists, metallurgists, engineers interrogate geological material, whether it's drill core, hole, cut, split, it's RC chips, blast holes, geometallurgical test work samples, soils. It's changing the way we look at things because now we can see, now we can use all this mineralogical information. But when it comes down to it, this is just an additional layer of information that geoscientists, engineers can use to improve their understanding of mineralogy and the relationships amongst minerals within their project. It's not the answer, if you will. There's a lot of work that has to go into, you know, how do you layer this into the existing models that you have, or to the interpretation in which you're currently working on. And like I was saying, it can be integrated into 3D models, data science workflows, as well as implemented into exploration, mines, geometallurgical and geotechnical programs. So thank you very much.